All right. Any questions? Thank you for coming to class. I think about 50% of the class is not showing up anymore. I don't know why.
Lord, is there like a file?
Yeah, there's one in the assignment. You just copy and paste into a file. Yeah, I posted PA4. I'll talk about it tomorrow in detail. But not surprisingly, it's going to be about string processing, similar to your ODPs. So those have been practiced for that. So issues with the ODP that was turned in today? Moving the character to the end? Or sorry, removing the first X. The thing we just did.
State variable?
Say again?
State variable?
Mm-hmm.
Is that a good way to do it?
Yeah, definitely. Basically, you got two states. You've seen your first X or you haven't seen your first X. If you haven't seen your first X, then when you get an X, you're going to remove it. If you have seen your first X, you don't care about X's anymore. They're just like any other character. So yeah, definite two-state system. All right, so here's a version of today's, the ODP that was due today. So remove one, right? Input string, output string. Pair of pointers, input location is where you're reading from, output location is where we're writing to. And I have a flag called done, which tells me have I already done what I'm trying to do, which is remove an X. So that's your state variable. So I initialize that to 0. For loop, and in this case I go up to and including string length of in. And if I read character string length of in from in, that's the null terminator. So I kind of cheat and pick up the null terminator in this loop so I don't have to tack it on separately at the end. And then the body of the loop is two statements. If the input character is not an X, I want to copy it to the output and increment the output location. Or if my done flag is set, meaning I've already removed an X, I want to copy from the input location to the output location and increment. And then I check the input character, and if it's an X, I set my flag to say done. And I'm going to set that every time I see an X, so that doesn't matter because I'm just setting it to a 1 multiple times.
Wait, how did you say you put in the null terminator at the end?
Because my for loop goes up to and including string length in. So this is this weird, right? So if my string equals ABC, 17, yeah. So my string is ABC, my last character is index 2. If I include the null terminator, that's at index 3. And string length will come back as a 3 characters. So the last character is usually string length minus 1. If I actually pull off character string, bracket, string length of string, that's the null terminator. So by looping all the way up to there, I'm also copying that null terminator. Or you could have put it at the end after the loop. So that will work for 417. But as usual, there's a lot of ways to do this. All right, for loops, while loops, add a null terminator at the end, set your flags differently. Most of the code that people showed me when they were trying to do this, they were using variable names like ijk or xk and w, right? And if those are meaningful to you, that's good. But if they're not particularly meaningful to you, use a meaningful variable name, right? It'll keep you from making sort of silly mistakes where you're using the output variable instead of the input variable or things like that, right? Don't be afraid to make long variable names. So when I started programming, it was in Fortran. In Fortran, you had very few variables available. You could have a letter followed by a number, and that was it. And your integers started with I through, I think, M or something. And so, you know, you had to use I1, I2, I3, things like that, right? And when I got to C, it was like you could spell things out. It was like nirvana. So don't be afraid to use more meaningful names if you think it helps you. All right, so 418, which is due tomorrow, and this is your last ODP for the week. I won't post one for, I won't post any more this week. So 418 is another function named move. Same setup as all these other ones we've done this week. It takes an input string and it returns a modified version of it. And the goal here is to take the first character and move it to the end of the string. So your output string is the same length as the input string, except everything's been moved down one spot and the first character is sitting at the end of the string. So if your input is A, B, C, your output should be B, C, A. In other words, everything comes down one position and that first character goes over to the right. So in Engineering 270, this is a rotate left, no carry. And I'll try to save you some heartache. If you call this and you pass a string like quote ABC, this should be the string that comes back. But if you test this using fgets, and remember fgets throws a new line on the end of your input, and you pass that string into your function, what are you going to get? Well, you're going to get everything shifted down, and that first character is going to come on the end. And so if you try to print this, it's going to look like this. That's perfectly correct. Okay, even though it's going to look weird. So either be aware of that if you're using fgets, or chop off the new line after you call fgets, or test it with, you know, something that doesn't automatically have a new line tacked onto it. Either something that you've hardwired, or maybe argv bracket 1 or something like that. But don't be tripped up by what would otherwise look like weird output. All right, and the rest is boilerplate, right? Link in with testbed, assess it after you've tested it on your own. So how do we do this? How do you take this string and push everything down one position and then move the first character to the end? Anything particularly tricky?
You could just say the first character and then run through it like you did with the X,
Mhm.
and then just put the other character on the end, and then put on an old one.
Yeah. So you can save this first character somewhere, right? Well, I mean, it's we're not changing the input, so it's already saved for us. So basically, you want to take character 1 from the old, put that into position 0 in the new. Take the second character from the old, put that into index 1 in the new, right? Keep doing that. And you got to figure out how far to go. And you don't want to include the null terminator because that's going to be weird. But go up to whatever the last character is. So in this case, it's character 2. We get copied to index 1. And then take character 0 from the old and put that into your new array. And you got to figure out what this position is. And then add a null terminator. So let's nail down the weirdness once and for all. Suppose your string is hello. No new lines here, just 5 characters. So the string length is equal to 5. This last character is 0, 1, 2, 3, 4. And the null terminator is character 5. So if you want to set the last character of your output, it looks like it's just string length of your input minus 1. And if you want to set the null terminator of your output, it looks like it's just string length of the input. All right, I'll save you one other potential heartache. Don't do this. What's wrong with trying to do the string length of, oh, sorry, no, do that. Don't do this. What's wrong with using string length on your output string? Doesn't work unless you give it a null terminator, right? So, danger. Because logically we could say new bracket string length of new equals null terminator to put it into the last position, but string length of new doesn't work unless it's already got a null terminator in there. So just be careful about that. Other than that, it should be pretty straightforward. I lost my network. That's okay. All right, so any other questions on ODPs? Or high-low? High-low's due tomorrow. Everybody done with high-low? Am I gonna have a good weekend playing high-low? All right, so we were playing with regular expressions yesterday. Any of these that you want to see or talk about? I don't know how far different groups got. Are any of these that left you confused? You can interpret your silence multiple ways. So let me just pick on one of these. Let's do this. Add an S to the end of any line that starts with a T. So remember, with regular expressions, we're substituting some pattern with something else, right? And in this case, we're trying to add an S to the end of a line. Well, we can't put something over here which just says append an S to a line, right? All we can do is say, take something, remove it, and in its place, put something else. So if we want a line that looks like the original line but with an S added, what we've got to do is match that original line and then replace it with the original line followed by an S. But we only want to do this, so if we just wanted to add an S to the end of a line, we could say start at the beginning of the line, match any collection of characters followed by the end of the line. And then we could say, let's put all of that into register 1. So this matches the whole line, and then let's replace it with the contents of registered 1 followed by an S. So that matches the entire line, and we can replace it with the entire line followed by an S, and it just throws an S on the end of everything. We could also have said substitute any character followed by the end of the line with that same character followed by an S, And so this will match the 9, the I, the T, the question mark, right, the last character on each one, and replace it by an exact copy of that character, followed by an S. So that does the same thing. Or we could just substitute a $sign with an S, because $sign matches the end of the line. We're saying replace that with an S. But if we want to only do this on lines that start with a T, we've got to make this pattern a little more interesting. So let's throw a T in the beginning. And now if your line doesn't begin with a T, this pattern will not match. It won't do the substitution. So it'll leave the line unchanged. But if there's an uppercase T in the beginning, then it will replace that line with the line followed by an S. Right, so the T is really just saying we're only going to match in that third and last line. And so those get S's added to the end. And it doesn't really matter if I put those parentheses around the anchors or inside the anchors, because those anchors don't actually match any character, they just match a position in the line. So if I include those in what's going into the register, it doesn't change the behavior. Right. I guess I put my anchors outside parentheses normally.
So what's the point of the parentheses? Let's say that there was no, would that still work?
Say the last part again.
Would that work if there was no parentheses?
If there's no parentheses, so what would I replace it with? Right, there's no \1 anymore because I haven't thrown anything in. So it just replaces it with an S. Right, so the parentheses are saying not only do we need to match this pattern, but whatever matches that, make that available in \1 so that we can put it in over there. All right, so PA4 is posted. I'm not going to talk about it until tomorrow, so you can finish high-low. But PA4 is going to involve a lot of text processing. Okay, it's going to involve taking strings, breaking them up, analyzing them, putting them together in different ways, all the stuff we've been doing with these recent ODPs. And we're going to be reading the strings that we're processing mostly from standard in. So we know how to use fgets. And fgets is nice because it reads an entire line of input, everything up through and including a new line, right, an enter key, and it returns that to us in a string. But for PA4, we're going to want to do something more subtle than that. We're going to actually want to read input one character at a time and do some processing character by character. So if you do a man on fgets, you get information on a whole bunch of functions: fgetC, fgets, getC, getCar, and ungetC. And they're all kind of similar in behavior. So getCar is the one that we're going to work with for the most part. And getCar is called without any arguments. You still need the parentheses to say it's a function, but we don't pass an argument to it, and it returns an integer. And getCar is actually equivalent to getC standard in, and getC is actually equivalent to fgetC. So get car is really just a way of saying f get c on a stream that's standard in. So let's play with this. All right, so if you're working with a function, you're not 100% sure what it does, write some test code, right? So here I've got an infinite loop. It's an infinite while loop. I'm just going to call getCar. I'm going to take the return from getCar, store it in I, and I'm going to print out the value of I. And it may strike you that getCar sounds like it's getting a character, but we're told it returns an integer, which is different from a car, right? A car is 8 bits. An integer is usually 32 bits. So I'm just going to print it out as a %d, but I'm also going to print it out as a character. And I'm going to print it out as a character inside angle brackets. So my printf is printing I twice, first as an int, second as a car. So we can see what it actually looks like. So I'll run my program get and I'll say hello. And it prints 6 lines of output. 72, 101, 108 twice, 111, and 10. So that integer, if you look it up or you remember, is the ASCII code for the corresponding character. Right? The new line, that's actually a control J, that's ASCII code 10. J is the 10th letter of the alphabet. If you run this on a Windows system, you may see a 10 preceded by a 13 at the end of the line, because DOS uses a carriage return followed by a line feed. ASCII code 13 followed by 10. But on Linux, it's just a character 10. So I can say 1, 2, 3, and it shows me that my getCar returned 49, 50, and 51, the ASCII codes for 1, 2, and 3, followed by a new line. So when you're sending input in through your keyboard, do you remember how you specify end of input? Control D, right? You hold down Control and you press D, and that's a way to signify I'm done providing input. It's called end of file. So if I do that here, I hold down Control and hit D, my return from getCar is now -1. And if I print that as an ASCII character using a %c, I get this weird diamond-shaped question mark thing. Okay, -1 is not a valid ASCII code. -1 as an integer looks like this. It's 32 ones. ASCII codes are 8 bits. Usually the most significant bit is a 0. But they're just 8-bit entities. But the problem is, since any combination of 8 bits could be a valid ASCII code, how can getCar tell us that this is the end of the file if everything that it returns could be considered a character? So getCar returns an int specifically so that it can return this thing which cannot be an ASCII code, this -1. So that we can say, oh, it's trying to tell me something, right? This is not the character that it read. This is a flag. It's a flag that says it's hit the end of the file. Now, Control D is not equal to -1. Okay, Control D is actually ASCII code 4, ABCD. But when getCar sees a Control D, instead of returning the ASCII code for Control D, which is a 4, it interprets it as saying, okay, we've hit the end of the file, and it returns a flag, which is -1. And now if I type hello, it continues returning ASCII codes for letters. Nothing really magic happened when I hit Control D except that getCar returned a -1. But it's still reading from standard in, it's still interpreting ASCII codes and returning those. And I can hit Control D a bunch of times and nothing's really changed, right? So if I don't respond to that return of -1, nothing really was affected by hitting Control D. All right, so Control C to interrupt your program. Don't use Control Z. Control Z is something different. We still have to talk about Control Z. Use Control C to interrupt. All right, so I'd like to respond to that -1. So I can throw in some logic here. So when I come back from getCar, I'll see if it returned a -1. And if it does, I'll print out a message and I'll exit my program. So now I can say hello, I can say bye, and now if I hit Control D, it says end of file detected and it exits. And that's great if we just want to exit the program when we find end of file. But if not, we could throw in a break to get out of the loop. But here's a more kind of traditional way to do this inside a while loop. So inside my while loop, I'm doing a couple of things. I'm calling getCar. I'm taking the return from getCar, I'm storing it in I, and then I'm seeing if that's different from -1. And if it is, I know I got a valid character, I'll go ahead and do the body of my while loop. But if I hit Control D, when I call getCar, I'll be -1, the while loop will fail, and it'll kick me out of my while loop. So you'll see things like this pretty commonly inside C code. So there's my hello, there's my Control D. Now, automatically for free, we can redirect standard in, because getCar is reading from standard in. So here's a file called data. It's got 2 lines in it, hello and 1, 2, 3. If I say get less than data, instead of reading from the keyboard, it reads from this file. And when it gets to the end of the file, again, getCar will return -1. That's why it's called end of file. And it tells me EOF detected, goodbye. So there's a special file in Unix called /dev/null. It's an empty file. It's always there, and it has nothing in it. So if I run my get program, but I try to read from that empty file, it comes back right away and says end of file detected. You can write to dev null, by the way, and it just ignores you. So it's a big black hole, bit bucket. I can also say something like date, right, which shows me my date. I can pipe that into my get function, and pipes are another way that we can change where standard in is read from. Now standard in is going to come from the output of the date command, and so my program reads that line of output from date and does its thing. So you kind of get all of that for free. So avoid magic numbers if possible. So -1 is the magic number that that's returned by getChar. But if you look in stdio.h, there's a statement in there that says define EOF to be -1. Right? And so instead of putting in a -1, we can put in the symbol EOF. And as long as we've included stdio.h, that's the same thing as typing -1. But it avoids having these special numbers. And when you read this code, if getChar returns EOF, right? And EOF should mean end of file. More than -1 means end of file. And if you fall asleep and wake up in 100 years and we've changed EOF to be -2, and this is your code, all you got to do is recompile it and your code still works. If you've got a -1 and we're using -2 for EOF, no, your code's not going to work. And you got to figure out everywhere that you had a -1 embedded that should be a -2. So we use these symbols, and standard I/O sets them up for us. And I'm guessing it probably knows what EOF is. Yeah, so if you don't include standard I/O, it says EOF is undeclared. So include that. All right, so this lets us read one character at a time. And PA4, we're going to want to do things within a line as opposed to just taking an entire line and doing something with it. And so you're going to want to use getChar or fgetc. So let's look at fgets though. All right, so I've got a character array of 120 characters. I'm going to call fgets. Tell it my array can hold 120. I'll print out the return from the value that's loaded into string, and we'll just loop on that forever. Right, so we've done this a bunch of times before. So fgets waits until a new line appears, and then it takes everything up to and including the new line and stuffs that into the first argument. And so this is a test, the string is equal to this is a test followed by a new line. And here, if I hit a Control D, it seems to just repeat the last input, which is kind of problematic. And so if I do get less than data, it just keeps repeating my last line. So when we use fgets, we also want to detect an end of line. And so the key is fgets will return a null when we're past the end of the input. Well, let's just do a break. I don't like breaks, but we'll do a break anyway. So now when we hit the end of the line, it says done with the loop, goodbye. But if you want to do that without a break, you can do something like this. So call fgets, which will load the return into this variable str, and at the same time use that in the while statement to see if fgets is different from null. If it is, it got a valid string. Let's print it out, go back to the top. When that while condition fails, then we kick out of the while loop, and we know we're at the end. So now I can read from a file, or I can read from standard in and hit a Control D. And that's better behaved. All right, so that's fine for standard in, and we can use a less than sign to redirect from a file, but sometimes we want our program to read directly from a file. Okay, and so we can use a statement fopen. We can put in a file name as a string, and a command which is a string containing the letter R. And this returns a variable which should be a pointer to a type of thing called a file, uppercase F-I-L-E. And then when we say fgets, we can put this right here. So I'm creating a fp variable, which is a pointer to file. I'm setting fp equal to fopen, and I'm asking it to open a file named data and open it for reading. That's what the R means. And then in my fgets, instead of reading from standard in, I read from fp. Right, so data is my 2-line test file. And then the rest of it's the same as usual. I'll do the fgets, I'll print out what I returned, and when I get a null from fgets, I'll go ahead and exit. And so that reads from my file name data and prints out its contents. So if I try to open a file that doesn't exist, I get seg fault. Yeah.
Where do you put the file if you don't provide a directory?
Current directory. Yeah, whatever directory you're running the command from. You were missing files before, right?
Well, do you know what it does on Windows? Because on Windows you just run the program. You don't necessarily have a directory.
It's a good question. I would guess the directory where the executable sits,
I couldn't figure
but
out-
maybe not.
Well, I was just doing debug, so
Yeah.
maybe it's putting in the product.
You might have to actually do a search.
Yeah.
Or you can run something to like print out your current directory. So here's the trick with fopen. If the thing that it tries to open doesn't exist or it can't read it, it'll return a file pointer of null. So we can check FP to see if it's null, and if it is, print an error message and return, and don't bother trying to use fgets. So if I run this and I try to open haha data, it'll tell me it can't open the file. But if I give it a good file name, it'll go ahead and it'll read it. And if I just print out my line that I read as a %s without a new line or anything else, my my output looks a lot like my file because fgets is putting new lines at the end. Right, so this is giving me a nice copy of whatever the input file was. Whereas if I put a new line in here, then I get an extra new line at the end of each line. And your file can be pretty much anything. So we can read from get.c, that's this program. And now my program's printing out a copy of its source code. I could do this on the file that's executable. I can open up this executable file get, and I get my gibberish, including elf. Right, so it really doesn't care what it is that it's reading. It can be a text file, it can be an executable file, it could be a device. Right? It could be something called /dev/tty, which is a shortcut for our keyboard. And now when I run this, it's trying to read from my keyboard, and I can say hello, and there's the echo. And when I hit Control D, dev/tty sends end of file, and I exit my loop. And everything on Unix is a file. Right? Memory is a file, hard drives are files, the network connection is a file. And if you look in /dev, there's all these files that are basically pieces of hardware, right? So there's a network, there's memory, there's 0, right? So we can cat /dev/0. Should be sending out nulls, but we can't see them, but it just spits out zeros.
Is the parentheses R, is that just how to read it?
The quote R?
Yeah.
Yeah, that's saying we want to read. And if you do a man on fopen, right, it'll spell all of that out for you. So the second argument is the mode, and if it's an R, it says open a text file for reading. So what if I make this first argument to fopen argv bracket 1? Right? I'm setting this up so that whatever I use as a command line argument, it's going to treat as the name of a file. It's going to try to open that file, and then it's going to go ahead and print out its contents. So I can say get data, and it shows me the contents of data. I can say get.c, and it shows me the contents of get.c. Right, this is basically the cat command. And if I say get gibberish, it'll say I can't open that file. All right, so that's the input side. We can also do output. So if we open it with a second argument of w, that means I want to write into the file. And when we're writing, we can use fprintf, and it works exactly like printf, except it takes the first argument, which is a file pointer. And we can say fprintf, fp, comma, and then everything that you normally do with printf. And instead of writing to standard out, it'll write to whatever file you opened and assign to fp. So let's open a new data file for writing. And we'll go ahead and we'll check FP to see if it's null, and if it is, we'll say there's an error. Otherwise, let's let's write some stuff into this file. So we'll open new data for writing, we'll print out hello, we'll print out some integers, we'll print out goodbye, and that'll be the end of the fun. So there's no new data in this directory right now. Let's compile this, and let's run it. And now if I look at new data, it's got my output. So if I try to open slash new data, I don't know if it's going to let me do that or not. Okay, it's going to say I can't open the file because slash is the root directory, right? And by default, you don't have write access to the root directory. Just like if I try to vi slash new data, nope, that's going to let me do it. Nope, it's not. So it's saying can't open the file for writing. So we check the return value from fopen here also. So we can read from a file with fgets, we can write to a file using fprintf, and they're both connected through just being able to use this fopen statement. You can open for reading or writing. There's other modes possible as well. You can open for appending, you can open for reading followed by writing. There's different commands you can put in the second one. They're not all a single character, which is why that's a string. But the man pages tell you how to do that. The last thing I'll mention here, and I do a little more on this in the first video, but you always want to close your file when you're done using it. So do an fclose call. And until you do that fclose or your function exits, this stuff probably is not actually written to the disk. So if I say, let's wait for a while, let's sleep for 5,000 seconds, and then I run my put program. Oh. So I run my put program and it's sleeping right now. There's a new data file in here, but its length is 0. And if I try to cat it, there's nothing in there. Even though I'm at my sleep statement, I've already done my fprintf statements. But those statements didn't actually go into the disk yet. And worse yet, if I interrupt my program, that stuff never got written out to my file. Whereas if you close your file, that forces everything that you've tried to print into your file to actually go into your file. The other option is to use an flush call. We'll talk about that later. All right, so tomorrow we will talk about the ODP that you just turned in tomorrow, and we'll talk about high-low, and we'll talk about programming assignment 4.